Real quick video here. How do you size an EPR valve, a Parker EPR valve? So that EPR valve is bad, and how are we going to size that puppy? Well, stay tuned. Okay, so what you do is you find your circuit. So we're dealing with circuit A2. Okay, so circuit A2, and we find the case, and we have to find all the cases on this circuit. So this is Hussmann model ID5 SL12, okay? And it's this entire line all the way down there, okay? And now we're gonna take a tape measure, and we're gonna measure how long this thing is. Okay, so real quick, you're gonna type in to Google your ID5 SL case. Okay, so you're gonna type into Google your dairy case, okay, and you're gonna find it. Now you can go to HussmannParts.com. If you're using Hill Phoenix, you can go use HillPhoenixBox.com, Southern or whatever you're doing. Okay, but typically if you just type it into the Google, you'll come up with the spec sheet or the data sheet. Okay, so now we're gonna go down a little bit, and on that data sheet, you're gonna find refrigeration data. You can see that in that corner right there, refrigeration data. Okay, so we're gonna go down here. It says application or whatever. So what we're doing is, so are the shelves lit? In this case, I'm going to use, yes, we'll have lit shelves, parallel rack, right, BTUs per hour. That's what we're looking at, right? And it's a dairy beverage produce. So if I go down here, I get 1040, right? And then if we look over here, you can see, I'm trying to underline. You can see it's BTUs per hour per foot, okay? So we measured the length of the case, okay? So I'm gonna go over here. So we measured the length, and we know that I forgot. I'll go back to here. So now if we read the notes, you wanna read the notes. We're gonna go down to the notes, okay? You see note 6. Subtract 60 BTUs per hour per foot for front glass. Okay, so if you remember, it has a front glass. We measured how long it was, and if there was multiple different kinds of cases, you'd have to do this for each kind of case that's on your circuit. But in this circuit, there's only like 4 of these cases all next to each other, so it works out very easy. And so we only need to do it for one kind of case. So all we had to do was measure the total distance of the circuit. So if we go over here, right, you remember that 1040 number? Because if we go back over here, right, you got the 1040. That's our BTUs per hour per foot. And then we're going to minus 60 from that because of the glass, because it's using less energy, which gives us 960 BTUs per hour per foot. Now we're going to multiply that 980, I think I said 60, my bad, by 52 feet, which gives us 50,960 BTUs per hour. Okay, that's how much BTUs that case is using. So now from there, you divide that BTUs per hour by 12,000, and that converts it over to tons. So you get 4.5 tons is the approximate. I think it's like a little bit less, a little bit more, whatever. But that's about what you get for it. That's a close approximation of what it is. Okay. And I concluded that you're going to use a SPORTII 1113 valve from that. Now, how do I get to there? So now that we have a tonnage, okay, what you're going to do is you're going to go and you're going to type in to the Google or whatever. So I have it saved on my phone. Okay, Parker, right, and you're going to type in this Flowcon. We're going to go up to the top so you can see what it is. It is Flowcon Pressure Regulations and Valves Catalog 611. Okay, this is going to be a sizing. So now that we have our tonnage, we're going to go to our refrigerant. Okay, so our refrigerant in this case is 134A. Right here, 134A. And you can see how it says tons right there. Okay, because it's going to also have another one for kilowatts that you can use, but you know, we use tons in my company, so that's what we're doing. So Evap Temp. So first off, you gotta say, okay, let me get my pen out. What's my evap temperature? Okay, well, my evap temp is 20. Okay, my case is targeting 30 degrees. My evap temp is 20 because it's 10 degrees below my case. You can double check that on the case spec if you want, but that is what we're targeting for this store. Okay, so now from here, pressure drop. Okay, we want the pressure drop to be in around that 2 to 3 range. Okay, so what is that pressure drop? So for instance, let's say if you need a pressure at the case of 50 degrees, okay? I mean 50 psi or whatever, right? And then you have your suction group that your case is off of. Okay, the pressure drop that valve is going to naturally have is going to be 2 to 3. So if you put in that valve, opened it all the way, your circuit would be 2 degrees higher than your suction group. On average, that's going to be about what it is, okay? Because it's naturally going to restrict the flow of refrigerant back to your system, which is going to elevate your pressure out at your case, okay? So for example, if you had a very low suction group, like let's say you wanted to put a medium temp circuit on a low temp rack and your pressure was like 20 and you needed to have your pressure out at the case at like 60, okay, you could maybe take advantage of this and use that pressure drop of 10. But my company likes to use an industry standard of 2 to 3 pressure drop. It's just kind of a rule of thumb that helps you for more applications. Because if you have that closer pressure drop, it's going to be easier as your rack swings through high load and low load. It's going to regulate your circuit better because now your circuit has a more fine-tuned, it's more fine-tuned with the rack. So like for instance, let's say if your rack got up to 40 psi or whatever, because of that huge pressure drop difference, your rack needs to be 10 psi below what your case on the floor needs to be. And because of that, it's going to rise. Like let's say you need it to be 50 out on the floor and your rack is 42. Well, on the floor it's going to be 52 because you have to have that 10 degree gap, a 10 psi gap. So it's going to vary more. So you want it to be this 2 to 3 psi. So as your rack swings with high load times to low load times, it won't screw up your temperature. So now from here, what do we do? So now from here, we're going to look for that 4.25 tons. Okay, so you can see that we can kind of achieve it in two areas. We can achieve it right here, and then we can achieve it right here. Okay, so you see how that's all in line, okay? So if I achieved it for this row, okay, we would probably get around a 4 psi pressure drop. And in this row, we're going to get around a 1 to 2 psi pressure drop, okay? So we're going to go with the 11. They thought it would best to go with a little bit oversized, so we know we have enough BTUs rather than the undersized one. But I think you can make a case for going with either one personally. So we're going to go with this column 11 right there, okay? So now what do we do? So now we're going to look at the part number and how to order it. So remember that column 11, okay? So now, go back up to the top. Come down here. Letters. Okay, nomenclature. So when we're ordering the valve, S. Yes, you want the S because you want it. If it has a solenoid on it, you want the electric shut off. So you can see that solenoid sticking out of the side right there. I want the electric shut off, shut on. So this is a suction stop solenoid. So you can get EPR valves without them. Like let's say if you had a liquid stop solenoid, you wouldn't necessarily need the electric shut off. All you need is an evaporator, pressure regulator. You wouldn't need that electric shut off. P for Parker. Yes. Open on rise of inlet pressure. Okay, so what does that mean? Well, if we look at our valve right here, okay, you can see that it's going back to the rack, right? So this is the flow of refrigerant, Okay, so this is going back to your rack over here. Rack. This is out to your case on the other side, C for case. Okay, so on the inlet side, where the flow is going in to the valve, so this is the in, okay, it's going to, no, that's not whatever, it's going to rise in temperature on this side, rise in pressure on that side of the valve, and on this side of the valve, it will be a lower pressure. Does that make sense? So when the refrigerant goes into the valve on that side, it's rising in pressure. So we want that because we want our case to have a higher pressure than our rack. Okay. Now T, inlet pressure tap or fitting. Yes, we want that right there, so we can take our pressure where we need to. II, aluminum bronze version. Yes, you want that because it will last longer unless you have a cheap customer that doesn't want to do that. Then you can get, I think, like a normal steel body with those rust and have issues. I recommend the aluminum body bypass feature. No, we're not going to use the bypass feature because if you see your EPR valve has 2 solenoids on it, then you would want to use your bypass feature. So this could be for something like a hot gas defrost, in which you could have everything controlled by this one valve rather than have like a separate piping with a separate solenoid. You could have it controlled by the same valve if you wanted. Port size. Okay, this is our column 11. Okay, so that's our column that we just went over a minute ago in the graph. So in this case, it could be 9 or 11, but we're going to go with 11. Okay, connection size 1/8 of an inch. So I measured, and I'm going to put 13 there. Okay, because it's 1 5/8. Okay, so it's 1/8 of an inch. So if you got to remember back to high school with, your mixed fractions and everything. Okay, so it's 1 5. Well, 5/8, okay, which equals the same thing as 8/8 plus 5/8, which equals 13/8, okay, which gives us that 13 number there, right? So remove that, put that back on, bypass feature, 11, 13, okay? So now we're going to go back to my notes. Okay, and you're going to see that the valve we want to order is an SPORT II 1113. Okay, so that's how you size and order an EPR valve.